Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
We assume that's the Bahamas. 544 miles per hour, 46, 56 degrees.
I'll just say, as a kid growing up in the middle of the desert, someone who ruled the oceans was the coolest thing ever. So, all right, so here we are, going to be talking about Primer, which is an amazing movie. So I'm glad everybody could make it. I know that originally we were postponed until yesterday, but you know, time travel, so glad you could make it. Okay, so I'm not going to try not to spoil anything about this movie too much, but spoiler alert, it is a time travel movie. So first, what we're going to talk about a little bit is the startup culture on this, because this also, especially at the very beginning of the movie, it almost reads like an episode of Silicon Valley. It just kind of plops you down into the midst of this bunch of people who essentially are trying to get the ball rolling on their own tech startup. So essentially, the first part of this film really kind of reads as what we see in the history for lots of different companies that end up making it big, is essentially you have people who have day jobs doing sciencey stuff, but not particularly exciting stuff or things that they are that interested in. So they essentially have a side gig, and they're working their hearts out trying to figure out something that is cool, something that will make money, something that they can build on their own, and essentially they want to become what in the tech world is known as unicorns. These are small startup firms that almost overnight become overvalued to like $1 billion. They get bought out by someone, and then they're all just living their lives on Easy Street. So this is, and especially if you've seen some of the other popular films or TV shows that kind of follow this culture, this is a very common thread that we see in Silicon Valley in the tech startup kind of world. One of the other things that is also very, very familiar and very similar to the stories that we know from history as well as from popular fiction is that almost all of the really exciting or important stuff happens by accident. And we'll see that in this film as well. Originally, you'll see there's going to be a bunch of jargon that's thrown at you by the narrator. And ultimately, what they're saying is we are trying to start to do this one thing, and along the way, we saw this really interesting side result that ended up being way more important and way more valuable than what we were originally trying to do. So again, this is a very common thread in what we've seen through history as well as popular fiction about tech and the startup industry. Another thing that's really interesting about this is this film made in 2004, I believe, is essentially telling the story of the Science Bros. So if you've seen any of the Iron Man films or the Avengers films, Science Bros, this is the same type of story. It's a bunch of guys that are working together inside of their garage, building some device in their off time, using their brains to their maximum capacity, trying to find a niche that hasn't been hit, somewhere that they can fit in, somewhere that they can make a difference and also make a name for themselves and make some money. Along the way, so they make this amazing discovery, and almost immediately what you'll see is the two people that were most involved on it try to keep it to themselves. They don't want the other people to be involved in this project once they realize they had something big. And this, again, follows along the history lines that we see from all the big tech firms that you know by name. So Apple, Google, Facebook, all of these were started off by similar groups of people that were doing this in their off time. And a couple of them happened upon something almost by accident, which was way more important than their original goal, and they start to try and limit the people that are involved on it. They want to keep it to themselves. This leads to then further kind of testing in secret, refining the technology, figuring out where they can kind of capitalize on all of this, and then some kind of a fundamental disagreement in the primary stakeholder. So the main two characters that we see will have a big disagreement on what they should do with this technology now that they can time travel back and forth a little bit. And ultimately that leads to the dissolution of the partnership. Usually, and again, looking at what we've seen in the history of tech startups, you look at what happened between Steve Jobs and Steve Wozniak at Apple. You look at Bill Gates and the people I can't even remember from Microsoft. Steve Zuckerberg and Facebook, like this is a very, very common historical thread and a very common thread in popular fiction and stories about the tech startup business. So all of that is wrapped up inside of this movie that is also going to really bend and possibly break our minds as we try to make sense of the time travel. So the way that they get to this is going through the scientific method. So we all have probably seen a very similar graph or something like this, or had to memorize something like this when we were all in the 3rd grade. And I'm here to tell you that as an experimentalist, this is not really how stuff happens. So this is all nice to understand and theorize how science actually works. It's usually a little bit more like this. I'm trying to do a thing. Along the way, something really interesting or really, really weird happens. And you're like, that's strange. Maybe I should try doing that again. Does it happen again? Oh, hey, it does. Maybe I could use that for something else. And if we look at history and a lot of the really, really great inventions, a lot of the really, really great innovations that we've seen in technology are byproducts of trying to get to some other goal. So things from what's known as colossal magnetoresistance, which is a really, really long phrase. Essentially, that's what lets hard drives be hard drives. That was along the way to try and do something else. It was a byproduct of the science and the technology, and they realized, hey, we can actually use this for something else. It led to something much, much greater. This is a very, very common theme that we see in history as well as in popular fiction, because that is how a lot of science works. You might have an idea of what you're trying to do, what you're trying to build towards, but along the way, something strange happens, and if something strange happens, as a scientist, you want to figure out why that is. And that usually leads off into these offshoots that lead to some of the greatest technology inventions and innovations that we've seen in modern history. Okay, so since this is a time travel movie, this is a nice little graphic that kind of explains some of the basics of the time travel that happens here. So if you'll bear with me. So the basics of this is, let's say that this is the universe. The stage is our universe. Along this direction is time. So time is going forwards in this direction. We, as sentient beings, don't really seem to have a choice but to keep moving forward with time, right? So what this movie does in this kind of concept is they build this device that when they turn it on, so we'll imagine there's some box here. When I turn this thing on, it's essentially a placeholder for me in time. So that even though I am just going forwards in time, I don't have an option, I keep going forwards in time, if this box still exists along all these timelines. But since I powered it on back there, if I get into it at this point in time, I can loop back around to that original point in time when I had first turned it on. So this is the basics of the time travel, the way that it's portrayed in this movie, is you can't go further back in time than when you started up this device. So this is the thing they build in their garage. It looks like a box. You literally turn it on, you let it run for some amount of hours. As those hours are passing, you're moving forwards in time. Then I climb inside the box, and that takes me back to the original point when I had first turned it on. So that's the basics of this, but as you'll find out, it very, very quickly gets really, really complicated. So yeah, I'll leave it at that. And now I think it's movie time. All right, so are all our brains a little mushified after that? Yes, okay, so I think we got the basics of this. Hopefully the basics of the time travel was pretty clear. So as soon as they turned on this device that they built, this box, that was essentially a placeholder in time. And they keep marching forwards in time, and at any point in the future, if they get in the box, it's going to loop them back around to where they started. So the thing that gets really confusing about the latter half of this movie is that there are multiple timelines going on, and depending on who you ask or which internet forum you read, we saw quite a few different ones of them. So the creators of the film also are intentionally a little vague about exactly what happened, just because that does make it a little bit more fun. But one of the things that's kind of critical to understanding at least the plot points of this was this thing they called the Failsafe Device. So this was essentially a second time box that they had built that Abe had put into a different room and turned on before he turned on the double ones when they started going back in time. So to kind of demonstrate this, I'm going to need 2 volunteers that want to be time travelers with me. So, okay, please come up. And one other? Yes? Thank you. Wonderful. All right, so wonderful. We are all now travelers in time together. Okay, so you guys can be our 2 main characters. This is going to be our original box. So the original box, they both get in at the same time. So we're all going to travel through time together. So if you guys want to stand next to each other, thank you. Okay, so we're marching forwards in time. Turn on the box, we're marching forwards in time. We spend the day goofing off in the hotel room. At this point in time, we get in the box, and what happens?
Go back.
We loop back around. Okay, so the trick was with the failsafe is you're going to be our failsafe man. Okay. So you essentially turn on the box here, which is a little bit previous in time. So remember, if this is our direction in time, we're all marching that ways. The failsafe is started before they do the double experiment. And so then essentially, even though we both are now, if you will move forward with me, so we're both all traveling forwards in time, even though one or some of our other selves might get in the box at this point and loop back around, he's going to go to his original spot, but you can come from even farther in the future, and you're going to loop around to farther back in time, because that's where the failsafe goes to. So this is why I kind of like thinking about how these boxes are essentially like placeholders in time. So even though the travel time is longer, what matters is when the box was originally turned on. That's where it takes them to. Make sense? Mm-hmm. All right, wonderful time travel. Thank you. Okay, and also, I don't know if you saw me sneak out during the film, but I decided to do a little time traveling of my own. You'll know it worked if, for some reason, we ended up winning World War II, and Wednesday now comes after Tuesday. Is that right? Okay. So as we saw with this, there were a lot of different time loops, and like I said, depending on how you look at the film, you could easily count somewhere between about 7 and 9 different times that people went back in time. So different loops, looping around and going back. And it can get very, very complicated, especially there are a couple of things like when they ran into the guy that was Abe's girlfriend's father, that was his venture capitalist. They were trying to get his attention and wanting him to invest in this company, this idea. And he just kind of randomly shows up and is essentially exhibiting physical symptoms that he's gone back in time too far and things are acting goofy. So you'll notice throughout the film, their hands, as they went back in time more and more, started shaking a little bit more. A couple of times they came out, their ears were bleeding. Things physiologically were happening to them. And there's this other just kind of event that happened. They don't even know when this guy got in a time box, which time box he got in, but he somehow had looped around and was now in this catatonic state. Yeah, so lots and lots of different things. This is like one of the most rewatchable movies ever. So you should go back and rewatch it a lot because it actually is pretty fun. So the way that, at the very, very beginning of the film, the way that they actually built this and the technology and the science they described, the creators of the film did a really, really good job of being accurate about this. So what they were describing is their original goal was that they were trying to build something to essentially create like a magnetic levitation, which is why they were measuring the mass of something, so its weight as it's inside of this little box. If they cooled something down to essentially what's called the critical temperature, where materials become what's called superconductive, then essentially they can start to levitate when they're on top of any kind of a metal or other conductor. The way that this happens is through what's known as the Meissner effect. And essentially what happens is that because the material starts to allow electricity to flow through it without any resistance whatsoever. That's what a superconductor is. The effect of this is that it effectively expels any magnetic field from it outside. So no matter what magnetic field you put this inside of, it will essentially kick it out once it reaches this critical temperature and becomes a superconductor. That's what they were trying to do. That's what they were trying to build and trying to sell. What they ended up happening across by accident was that this ended up somehow also allowing them to have this kind of feedback loop in time. And that's when they saw the biofilm that was growing on whatever they put in there that was from this type of a fungus that is everywhere and excretes this protein. So all of that mumbo jumbo that was at the beginning was all based off of this. Like I said, it's all really sound science. Whether it can actually make you loop back in time is where we have our suspension of disbelief, but I will say it's at least not disproven. So a lot of this is leading up to the question of what is time? And the film wrestled with this a little bit as well. Specifically, they talked about like the time paradox. What if you go back and alter something? Is that going to change a timeline? Or if we think of like other time travel movies like Back to the Future, does that make people that start to kind of fade in and out or disappear? And ultimately, what science and physics tells us is that that's not really the case. And there's a couple of different ways that we can think about this. So time itself is something that's kind of nebulous. It's not something like mass or energy or other things that physically we can measure quite easily and have gotten really good at, or even distance. And it's not like there is a particle of time that you can hold in your hand or that you can isolate or measure, which is one of the things that makes it kind of difficult to decide exactly what time is. So one of the most popular ways to kind of think about this time thing and what it really is that it's essentially measuring the differences between states of the universe. And we, as sentient beings, seem to only be able to travel in one direction in time. And we aren't really able to change that whatsoever. So one way to think about this is like the example that I was using at the beginning, is that time is really just another dimension. We just really suck at moving any way but this way at it. So in multiple dimensions, you can think of this as one dimension. We can call this X, Y, Z, which is what we usually do in science or physics. And we're pretty good at this, right? We aren't great at it when we're born, but we pick it up pretty quickly. We're good at manipulating things in these three dimensions. So we can think of time as just being this extra dimension that we are steadily moving through. We're just not very good at changing the way that we move through it. So that is all good and fine. And that is essentially what the premise of the movie was built off of, is that time is something that there aren't these time paradoxes that if you went back and killed your grandpa, you would still be around. You would just be back in this other time period, because essentially all you're doing is going through here and you figured out a way to move through this other dimension that other people are not very good at moving backwards in, that everyone else is just very good at moving forwards in. So that's the way that we think about time as it pertains to science and as it pertains to physics. Okay, so essentially we are all time travelers. And this is also something that came up a lot when relativity and quantum mechanics and other types of things were happening at the beginning of the modern age of science. So this is in the early 20th century to the mid 20th century when a lot of this thinking and experimentation was happening. And so essentially we can view just time as this one other dimension. And there's, this is one of the ways that Einstein kind of described this, is that there's this future cone and this past cone that are all the possibilities that you could have in the future and all the possibilities that you could have had in the past. And that essentially what we experience is this little red line that's kind of weaving all of these moments together. So it's stitching these moments together in time, and each of these moments is what we call a physical state of the universe. And there's a lot of information that can be held in this state of the universe that has to do with the position of different atoms, which you are all made of the energy of all of your atoms, which you are all made of, the momentum of the atoms that you are all made of, the charge and the mass of all the atoms that we are all made of. That essentially any slice in time, any brief instant in time is just a collection of data of where all these things are in time, and time is just stitching all these different states together. Now, one of the things that also got a little bit weird with modern physics and the invention of quantum mechanics and discovery of that is what's known as space-time. So we may have all heard of like the SpaceTime Continuum. Like that's actually a thing. And that's actually how we think of stuff in science. So again, this was getting back to Einstein, Fineman, Dirac, and some of the people back then that were the inventors and sort of the champions of this at the beginning. And one of the things that Einstein's relativity theories brought together that was really kind of novel and really made people kind of stop and have to change their view of what the universe was, is that space and time were kind of woven together and that you couldn't really extract them from one another. So this is now how we kind of think of the universe for most of the type of science that we do, especially on really large scales and also on really, really small scales. So space and time are everywhere. You can take all the stuff out of it. We can have what's called a vacuum. That's when we remove all the atoms, all the light, any kind of radio waves or anything like that. We can suck it all out and have something, and it is this thing we call empty space. But in this space, there is also time, because time is still moving forward inside of this empty space. So they are kind of inextricably linked together. The way that we tend to visualize this is as this kind of a grid. So we call it like the fabric of space-time. So you can kind of think of like a sheet of paper or some kind of a cloth. And what happens is in really, really large gravitational fields, such as you find around stars or black holes, this fabric of space and time will actually stretch some. So if you're really big into time travel movies and sci-fi movies and stuff like that, you've probably also seen Interstellar. Yes, did we like that one? Yes, I like that one a lot. You should see it. And in that, what we saw was people going down to the planet of or to the surface of a planet that was inside of a really strong gravitational field, and time passes differently for them than the people that were up in the spaceship orbiting the planet. And this is totally a real thing. This is something that we have measured lots and lots and lots and lots and lots and lots of times. And it's totally real. If you go really, really fast, close to the speed of light, or if you are in a really, really big gravitational field, this stuff that is space and time together literally stretches and expands. It's called time dilation. And so that means that what you experience as time in there is different than what someone outside watching you is experiencing. And so this brings up what's known as the twin paradox, which is where if you have two twins that are born, one of them gets on a rocket ship and blasts off and goes close to the speed of light to the nearest star, turns around and comes back. For them, maybe 3 years has passed. For their twin that is back stuck on Earth and has not been going very, very fast, they have aged and died. So they've gone through their, say, 60, 80 years, depending on how fast you go. Their entire life has passed for them because time is going differently for them. And this is kind of why time is one of those things that's really enigmatic and a little bit hard to wrap our heads around with science, because this is not what we would expect, that just because I went fast that way and then came back, that time passed for me differently than someone that was sitting there. Okay, so that's a little bit about exactly what time is. So with space-time, one of the other things that's really interesting about it, and this is actually a really big question that is left as far as what time really is if we take up this stuff that is space-time, that is the universe, and we chop it up into really tiny bits. The question is there a tiny bit that you end up not being able to chop up anymore? So with matter, with stuff that we are made of, we call these elementary particles. So like electrons, protons, those kinds of things that we've talked about. Right? At some point, there's a tiniest bit that we can't chop up anymore. And so one of the theories and ideas of this is that space itself, even just empty space, has some small finite amount that you can chop it up into, what we call the Planck length. And what's even weirder is that time itself may have this factor into it as well, that there is some finite amount of time that there's literally no existence between these two ticks of time. And the Planck time is about 5 times 10 to the minus 44 seconds, which is a really, really, really small amount of time. It goes by very, very, very quickly. But that is the theoretical limit for how small little bits of time we can chop this up into, which is pretty interesting. Okay, one of the other things that was mentioned in the film, they mentioned Fineman diagrams, and I know that the creators of the film actually went and read up a lot on Fineman diagrams and used that as some inspiration for coming up with how they were going to do this time travel theory. And so one of the things that we have here is essentially these were pretty pictures that this very crazy and interesting scientist named Richard Fineman came up with because he hated doing really hard math. And so he came up with these pretty pictures that essentially represented the math so that he didn't have to do it all the time. And so every time he drew something, he knew what math that meant, and that's what we call a Fineman diagram. So what we have here is an electron, which is up there on the top left, that is hitting a positron, which is like an electron, except it's its antiparticle, and we have time marching forward in the right-hand direction. When these two things smack into each other, they go through this thing that's called an annihilation, and they give off all this great energy in gamma rays. What is interesting is that Fineman, the way that he drew this, it actually looks like the positron, the little E plus that's on the bottom left, is moving backwards in time. You'll notice that its arrow is kind of slanted backwards and to the right. That is literally going backwards in time. And the reason that he drew it this way is because for the very complicated equations that go into this funny little drawing, there are some solutions to the equation that have negative energy states. And the only way that he can make sense of that was to imagine that this positron is actually just an electron going backwards in time. And so again, getting back to what is this time thing, it seems to be this just connection of discrete states of the universe, and there's nothing in the laws of physics that say that things can't go backwards in time, and there's nothing in the equations that don't allow it. And if you do, funny little things happen, and these are actually things that we observe. And so this is one of the ways that we try to make sense of these strange mathematics that we get whenever we're looking at really, really tiny stuff. Okay, one of the other really popular ways of thinking about time travel in sci-fi movies is through what's known as wormholes. And so this is also built off of the idea of SpaceTime Continuum. And essentially it's finding ways to take this SpaceTime Continuum, which is like this big sheet of existence that encompasses all the different directions we can travel in and all the time that ever was, and finding two different points in time. You just bend space and time together so that 2 points touch, and now you can travel from somewhere that was in the future to somewhere that was in the past. And it takes a lot of energy to be able to kind of wrap this stuff around so that you can make this little point. You can travel back and forth in time. But again, there's nothing that says that you can't do this. It would just take a tremendous amount of energy. And this is also one way of kind of theorizing and understanding this looping back that we saw inside of the movie Primer. That essentially by setting up this Meissner effect, they were essentially creating this tiny little wormhole that is inside this little box, which is connected back to that previous point in time. That is this connection that lets them loop around and pop back into a previous point in time, just the same way that you would travel in any other kind of dimension. Okay, so, yes, I know it's really bad. I really love really, really bad puns. So that is about all that I wanted to share with you guys about time travel. So let's start talking and have some good questions or discussions. Okay, questions?
I'll start with a question.
Yes.
Okay, I've seen the movie a few times, as you all know now. But one thing I forgot about and can't quite make sense of is there's a point where Aaron, who's the one with the dark hair, said that he disassembled one of the boxes and put it inside the other box.
Yes.
So is there anything you can say to explain why he did that and what effect that had?
Yes, so one of the things about these boxes is you can only have one person in it at a time. So like if I turn on the box here and I keep going forwards in time and then I climb into the box at this point, I'm going to be looping back around, but I don't want someone else getting in the box while I'm going through this process, because that could totally screw things up and could be catastrophic. So what he did was essentially fold one up, take it with him, he marched forward in time, he got inside the box, that loops him back around, then he goes to another room and sets it up there and turns it on. And so now he doesn't have to worry about this one being used. He can, at any point in the future, come back and get in this one and loop back around to the same point in time. So it's essentially creating multiple points that he can, or multiple ways that he can jump back to the same point in time if you have multiple boxes that were all started at that same point. So that's why he did that. Does that make sense? Kind of. I know.
Is it sort of like another version of the failsafe?
Yes.
Box then?
Right. It's just that it would be powered back to that same instant in time. So as soon as he got out, he would have to go and reconstruct it in another room and turn it on. But then he wouldn't have to worry about these being in use. At any point in the future, he knows this other one is still running, and so he could get inside of that one, and it would pop him back to the same point in time. Yes?
So you talked about the things that they did right and the physics that they got right. What did they do wrong? Like where do you see the failing?
Okay, as far as the physics and kind of our suspension of disbelief, just some kind of back of the envelope calculations for like the amount of energy it would take to bend space-time this way, they tend to be enormous. Like multiple stars and black holes worth of energy in order to do this. So that's one place that like we're kind of suspending our disbelief, is that if this is possible, the amount of energy that it would take to literally warp space and time that way, just the amount of energy is enormous. But other than that, like all the jargon, the lingo, the things they were talking about totally makes sense. I don't know why they would measure things in decagrams. That's a little weird. Like, people don't use decagrams. It's not like the 1850s. I don't know. I mean, the metric system is great, but decagrams, why not just grams? It's like 1 decimal point over. So that's my only other nitpick. Yes?
They got in the box, and there was 2 of them, not just one. There was 2 of them, and they were breathing oxygen because it was argon in there or something.
Right.
And then you saw them in the hotel, and you said they were marching forward and they were in the hotel. But why were they in the box so long? Are they in the same place? It's just a difference in time?
Could you phrase that one more time?
They were sitting in the box, aren't they? They're breathing all that gas, okay?
Yes.
So, then you see a picture of them in the hotel, and you said they then go back to the box, don't they?
Right. So what happens is, so the way that we perceived it and the way that they would perceive this is, again, if we're marching forwards in time. So I come over here and they just flip the switch and get the box started. Then they go hang out in the hotel all day, and because they don't have a choice, they're marching forwards in time. When they go back to physically get in the box, it's been flooded with argon, because in order for them to cool the thing down so that it becomes a superconductor, it needs to be in an inert atmosphere. So it can't be stuff with oxygen and some of the other stuff that we have in our normal atmosphere, because it's much more reactive. So that's why they took those tanks with them when they got into the box, is because it was still flooded with argon, because they needed to do that to cool it down to get to the superconducting state so that the thing actually did the time loop. I hope I answered your question. Okay. Yes?
So we're made of matter.
Yes.
And even if we could travel in time, we couldn't double or triple the amount of matter that we're made up of, so how could we create multiple versions of ourselves?
Right. That is a very good question. So what this gets at is what's known as the conservation of matter, conservation of energy laws. So in physics, we have things that we say are conserved, but that is all with respect to time. So if you've heard that energy can't be created or destroyed, that is this exact idea, and matter is just another form of energy. The thing is that those conservation laws are relative to a point in time. So if you are taking things from literally one point in time and bringing them back to another, there's nothing that says you couldn't, because the overall energy that's in the universe is still there, right? It's not like we are adding or removing energy or mass from the overall universe, we're just rearranging it. So if time is just this other dimension, essentially we're just going in the time dimension, we're grabbing a person and dragging them over here. We can do that in other dimensions. There's not really anything that says that we couldn't do that with respect to time. Does that make a little bit of sense, I hope? Ish.
Why are there doubles then? How come there are multiple versions of them?
Because we've just moved them from one place to another. That's all. Their matter is still there, their energy is still there. We're literally just moving them in another dimension.
But like when they got out of the box and they were outside on the truck with binoculars and watching themselves, so there's multiple versions of them.
Yes, absolutely. But that's totally okay.
That's okay.
That is. I mean, they end up knocking themselves out and tying themselves up in the attic too.
Right.
You know, like they end up even like physically interacting with each other in this visceral way. And yeah, that's totally okay too.
So going along with that, why did they knock out the other cells and put them away? And but what I know Aaron, I think, went all the way back to stop himself from creating the machine in the first place.
Right. So here's what I think happened. So like totally not my realm of expertise is this film, but what I think was happening was you had multiple Aarons that have jumped back in time, or Abe went back in time because he was going to prevent it, and then you had Aaron jump back in time because he wanted it to keep going forward. And so when you saw him injecting the syringe of the stuff into the milk, he was knocking his previous self out and then taking him up into the attic. But then right after that, there's another scene where he's fighting with another one of himself in front of the fridge because apparently another one came back around and wanted to do it again, but he had already done that once. And so they end up having a scuffle in the kitchen. So all of this just has to do with, like, even there was one other scene where he very kind of forlornly is looking at himself. One's inside the house, one's leaving the house. He said, like, that Aaron wanted it more. So apparently, like, different parts of him from the future had this idea that they really wanted to keep doing this, or that I'm done, I'm walking away from all of this. So I don't know what that says about the human condition and their motivations, but every time that they went back, it was to either prevent something or alter something. So the other thing that they kept going back multiple times for, we know from the narrative of the film, is this random work person's cousin that was Rachel's ex-boyfriend that came in with the shotgun, right? And so one of the things they wanted to stop this from happening because they were worried this guy was going to end up at some point hurting Rachel, but also kind of allows them to live out this hero fantasy. I mean, if you knew that something quasi-bad was going to happen, why wouldn't you go back and try it multiple times until you got it just right? You got to be the hero. Why wouldn't you do that? And that's exactly what they did. And so in the narrative, again, it's a lot easier if you rewatch this a couple of times because you start picking up on more and more pieces as you rewatch it. But there's always some motivation of either stopping a previous version of yourself because you know what they were going to do, or altering something that you were not happy with in the past. Again, I have no idea if I actually answered that. So, follow up? Okay.
You say that it takes a lot of amount of energy to go, like, to be possible to go backwards in time, right?
Yes.
So, if nuclear energy is the one that we almost say is the huge, the almost like the biggest one that we have, and nuclear energy unstable can kill humans in just a matter of minutes. How is it possible to make this, like, if it is possible to make to get backward in time, how is it possible to do the life?
Okay. Well, for the purposes of this film, they didn't use all that much energy. They used 2-car batteries, right? So slightly more safe than building your own nuclear reactor or something like that. How you produce the energy is kind of a moot point, just because the main thing is just you need lots and lots and lots and lots of it. So there's been some speculative fiction and stuff that's been written, and I think it's even made its way into some movies and TV shows where people will literally build like collectors around a star. So it's essentially you encapsulate a star with this thing that is just harnessing all of the different forms of energy that are coming out of it, different forms of electromagnetic radiation, as well as really hot ions and plasma that's spewing out of stars. That would be a really, really great way of harnessing all this energy. And then essentially you just have to put a big old plug into it and connect that to your thing. So we can kind of imagine some ways where it might be possible, but it's probably not plausible in the near future. Other questions? Here. I think there's some in the back. Yeah, sorry.
Yeah, at the very end, what was Aaron doing? Was he making, like, I was just confused about his job. He was like a leader of...
Oh, yes. So the very last scene where he's in this big warehouse and talking to some people speaking French, right? Yeah. Right. So what that appears to be to me is that essentially he said, screw it, I'm going to go fly somewhere where I can get cheap labor. I'm going to buy a really big metal warehouse and turn it into a giant one of these time loopers. And that's why when he was saying, what was it, 50 centimeters? Or every half meter, and he said everywhere, that was all those metal little pieces that they need to produce a strong enough magnetic field inside of this giant box. So with the boxes that they had laid out, you saw that there were these little silver plates that were periodically spaced around it. Those were there because they were creating this magnetic field on the inside, which we needed for the Meissner effect thing that they talked about. And so essentially, instead of having one really big magnet, you just have a whole bunch of tiny magnets, and all the fields add up together. It's an additive effect on the inside, and you still get the same strength of the magnetic field. So it seems like that's what he was doing in like an airplane hangar or something like that, was just making a really, really big one of these. Other questions? Yes?
So the narrator, was that the air in the warehouse? That's kind of what I got.
Yeah, I believe so too. Again, depending on which internet forum you read, might not get the same results, but that's the way that I saw the film, is that he was the one that was ultimately narrating. And there's also an interesting part in when he goes back and knocks himself out, and then another version comes back and he tussles with him in the kitchen. At that point in the film is where he said, or where the narrator says, and this is where I either enter the picture or exit it depending on your reference frame. And so that kind of clues into me that like the one with the hoodie that ends up leaving, that is the narrator, and that's the one that's in the airport talking with Abe, getting ready to leave, and then he ends up somewhere where he gets cheap labor, gets his airplane hangar, and is building a giant one of these. Yes?
Something you keyed on earlier, and it seems like in whether it's on Iron Man or Star Trek or this movie, huge amounts of power are needed to kind of limit this stuff. Based on your view right now, are there any feasible potential power sources or avenues of finding that kind of power?
Right now, what I'm seeing in up-and-coming research is getting away from gigantic power source and moving more towards lots and lots and lots of really small power sources. So talking about like wearable technologies, small solar collectors, even small thermal collectors. These are things that like fabrics that are woven into your jacket or your pants or something like that, so that as you are walking around, the bending of the fibers creates a very, very small current that then goes to a very small battery that can power something. or even putting really small thermal collectors, which if there's any kind of a temperature difference, you can get a little bit of charge to flow, putting those in different type of manufacturing processes, putting those in your brakes so that every time you step on the brakes and they squeeze together on the brake discs and heat up, that you're able to squeeze a little bit of energy back out of it. That's one of the big growth areas that I see in research right now, is going more towards lots and lots and lots of really small power plants, essentially, or ways of creating energy. Yes? Oh, I'm sorry, I keep missing you in the back. Yeah, go ahead.
So you were talking about how we have time dilation at relativistic speeds.
Yes.
So that kind of becomes a problem when we're dealing with GPS satellites. We see the clocks on them run slightly faster or slower, one of the two.
Yes.
The clocks on Earth. Does that have any other practical or implications in the rest of the sciences?
Yeah, GPS is probably the most practical application. And there's kind of a funny story / legend in the scientific community that when they started off doing this GPS stuff, I think that originally they started it in the Air Force in the 50s, and it started to gain steam in the 70s, but they were having a really hard time making it more and more accurate, and they always tended to be off by about 15 meters. And it wasn't until some physicists that they had brought on board for the team, they were looking over just like the baseline algorithms that they were using, like, oh, well, these things are moving really fast. Why aren't you using this 1 over the square root of 1 minus v squared over c squared, which is this relativistic speed thing? And they're like, what are you talking about? Because they were engineers, and they're like, yeah, we totally glossed over that part when we went to school because it has 0 applications. But now we put these things up in orbit, and they're starting to actually go kind of fast. So that is the best example that I know of where relativistic speeds actually matter. I guess in kind of high technology and high science stuff, what they're doing over at the Large Hadron Collider, they're accelerating some electrons up to, I think it's like 99.9995% the speed of light. And so for them, for those particles, like, yeah, definitely it's a very big deal, but that's a very limited application, so that's only like a research application. So sorry, I don't have any, that's the best example, so keep using it. Yes?
Switching bends in time and connect with each other and break?
There doesn't seem to be a limit, except for maybe inside of a supermassive black hole. Kind of hard to say because we don't really know. Yeah, the way that space-time can stretch and bend when either we go really fast and it kind of squeezes or stretches apart, or you have these really big gravitational fields. The problem is we haven't been able to get really close enough to measure what is happening inside of that. And at least mathematically, there are some issues in understanding black holes and what's happening inside of them with what's known as the singularity, in that it seems that all of the energy and the mass is being collected into this infinitesimally small little pinprick of a point in space. And how can that be? And if the mathematics, essentially, you end up going as 1 over infinity. We called it the singularity. And it doesn't really make sense, or we can't make sense of that if the mathematics are correct, and they seem to be correct, or at least mostly correct. Hard to know because we can't measure it. So that's my best answer is a woo.
And then 2 follow-up questions. I heard that there might be a black hole in our sun, and is a rift in the space-time continuum theoretically possible?
Okay, as for the black hole inside of our sun, if that was the case, our solar system would be a much, much, much worse place to live. So, despite whatever current conditions are, yeah, it would be a lot worse. So, I don't think that's possible unless this has to do with the idea of really, really tiny black holes that kind of pop up into existence and essentially are satiated and kind of wink out of existence again. which might or might not be a thing. That's something that I know people are still researching and looking into. And what was the second part? The riff? Oh.
Is it right from the space time to theoretically possible?
Theoretically, yes, but does it, again, that's one of those things that if we look at the math of what that would look like, we don't really have a way of wrapping our heads around that or saying like, what would that actually look like? And part of this also kind of gets to the idea of like a universe. And I talked about like space-time as this big flat kind of piece of paper or fabric. Well, what's above it or what's below it? It's not even nothing, because nothing is just empty space, but it's still space and it's still time. And so like, what are the edges of our universe? Are there things beyond the universe? Totally possible. How do we conceptualize that if it's not even space and it's not even time is a little bit difficult and something we haven't quite been able to wrap our heads around. And something that we also haven't been able to test. But theoretically possible, absolutely.
I think we probably have time for one more question. There's got to be one more out there.
Yes.
If you were to make a time machine, or say you have it here and go back in time, well, that's going back in time is one thing, but like this room wasn't here an hour ago because the Earth is rotating.
Yes.
The Earth is going around the sun, and the sun is going around the galaxy. So like you'd also have to be concerned with where.
Yes. Yeah, you are absolutely right. And that is also one of the things that really bugs me about sci-fi, is that is something that a lot of people and a lot of speculative authors or creators have not really considered. Because you're absolutely right. Is the reference frame that we're usually thinking about is that the Earth is standing still, but the Earth is far from standing still. We're going very, very fast around a sun that's also going very, very fast around a black hole that's in the middle of our Milky Way galaxy. So yeah, that's something that should be addressed. Depending on how you travel backwards in time, you could also kind of key in that it goes to the same spatial coordinates as well as time coordinates. So like if our box was a placeholder in space, maybe it is also a placeholder in other dimensions, so the spatial dimensions, if that makes a little bit of sense. So that's one way to kind of get around it, but it's something that certainly doesn't seem to be addressed very often.
Yeah, I've never heard of it in TV shows or movies that it seems to never address that.
Right, right.
Okay.